Hello, I'm Kevin Carlson with Crysalli, and in this video we're going to show you how to change the ice bank control. So what we've done is we've pulled out the CRUCM1 system out from underneath the cabinet to access it. And what I want to point out is some of the different components. What we have here, this is the ice bank that has built up on the evaporator coil. This is a normal looking ice bank for this particular system. The other coil that you see in here is, this copper coil is a water coil. In some of our later or more recent models, this will be stainless steel. And then what you have here is a carbonator tank, and then you have an agitator recirc pump here. So what we've done is we filled this bath, we're building up an ice bank. The agitator pump is recirculating the water across this ice bank, moving the water across the water coil, which is pre-chilling the water coming from your city water inlet. And then it's also, we're storing carbonated water that's submerged into this ice cold bath, so we're able to deliver cold carbonated water to the dispense tower. So as I mentioned, this ice bank is actually normal. So in normal circumstances, we wouldn't need to change the ice bank in this situation. But you may have a situation where this ice builds up and it continues to grow beyond into the water coil, into the carbonator, or even the whole bath freezes over. That would be an indication that the ice bank control didn't shut the compressor off, didn't shut off the refrigeration system, so it continued to build up the ice bank beyond the normal thickness that we want. Another situation would be maybe you don't have any ice bank built up at all. So maybe the ice bank is not opening up, allowing the compressor to run. So then we need to troubleshoot to see if that's truly the case. So let's assume we have a warm water bath, the agitator pump is running, we don't have any ice bank buildup, and we want to determine whether or not it's the ice bank control that's the problem, or is it a refrigeration related issue. So if we have a warm water bath, no ice bank, and the fan is actually running, the fan motor, then you have a ice bank that is functioning, but you have a refrigeration issue. So the second scenario would be we have no ice bank built up, agitator's running, we've got warm water in the ice bank or in the ice bath, but the fan motor's not running. If that's the case, then we know we have a bad ice bank control. So to begin it, the first thing we're going to want to do is shut off the power to the chiller system, and then we need to drain this water bath. So go back to this white pipe stem. We're going to pull this out. I like using a pair of needle nose pliers, and then I'm going to want to set that somewhere, and then we're going to let this bath completely drain. Now that white pipe stem was connected to a 3/8 drain line that should be connected to a drain or your floor sink. Once that bath is empty, then we'll begin the next step. So part of the longest process of changing out this ice bank control is going to be to melt the ice block that's built up in here. So we definitely got to completely defrost the whole thing. First of all, to access the existing bulb that's in there, but we also need to completely melt down the ice bank, so when we put the new one back on, it starts off with a bare evaporator and we build evenly. So what I'm going to do is I'm going to start by, one method is just using water. So I'm using water off the filter, and I'm just going to use ambient water to run it across this ice bank, and that will help speed up the melting process. So another method that's been used, seems to be an effective way of melting this ice block, is using a heat gun. So one of the things you want to make sure, these heat guns, they obviously get extremely hot. You want to make sure you keep that direct heat away from some of the plastic tubing and wiring in here. So I don't recommend putting it on high, but putting it on medium to low temp to help speed up this melting process can be an effective way. Let's assume that this ice bank is completely frozen over. Obviously, it's going to take a long time to melt that down. So my recommendation would be just shut the system down, shut the water, the power, the CO2 off, and let the customer know we're going to have to come back tomorrow or in a day or two once that ice bank is completely thawed out to continue the process. And under no condition, you don't want to use tools or picks to start picking at this, because the likelihood of you hitting the evaporator coil or hitting the water coil or damaging something is greater than what you're going to accomplish by using a pick. So let's not use any tools to try and break up this ice bank. So the evaporator coil, the ice bank that's built up on the evaporator coil, is completely thawed out. We've drained the water bath, and now I'm going to go ahead and install the white pipe stem back into place. It's in there somewhere. Insert that completely. Then the next thing we're going to want to do is we're going to remove this bracket that has the ice bank control bulb on it. So there's a zip tie that's holding that to the evaporator. I'm going to go ahead and cut that zip tie and then remove the bracket. We've removed the zip tie. Next, just slide this bracket up off of the evaporator coil, and then there's a Phillips screw here. We're just going to unscrew that and remove the bulb from the bracket. Actually, you just need to loosen it, and then it should just slide right out. I've removed this bulb from the bracket, and one thing I want to point out is this bulb is actually, and the cap tube that goes back to the controller is actually charged with beryllium, which is a toxic element that you don't want to ingest or come in contact with your skin. I've removed the panels from the chiller, and now I'm going to carefully pull the element, or not the element, but the bulb back to the control box. So now we're going to access the terminals for the ice bank control, and we're going to have to remove a couple of terminals from this the electrical board enclosure. Before removing the cover plate, one recommendation would be just to unplug the chiller, just to take that extra safety precaution to make sure that there is no power going to this. So I've unplugged the system, and now we're going to remove this control plate cover. So I removed the cover plate, and as you can see, on the back side of the cover plate is the electrical board schematic. So the two terminals, wire terminals that we're going to remove, is in the upper right hand corner. You'll see it says IBC1, which is a black wire, and then below it is IBC2, which is a white wire. We're going to go ahead and remove those two from the board. Now we're just going to pull these wires through the grommet that's on the side. Kind of got to wiggle them. They will come loose. So now we're going to remove this controller from this bracket. So there's two screws, these two Phillips screws. We're going to just unscrew those and remove the controller. I've removed the Renko mechanical ice bank control. So this is the device we've just pulled out of the system. And what I'm going to do is we're going to replace it with the new electronic ice bank control. So before I go too much further, the old ice bank control, the mechanical ice bank control, is equipped with 2 wire leads and terminals. And then the new one actually has 3 wire terminals. So later in the video, I'll show you how to make the connection and where we connect the 3rd wire on the circuit board. I want to focus on the components that come with the new ice bank control, or the electronic ice bank control. First, we'll look at the actual controller. This is the electronic controller. This system is actually, it's manufactured by Danfoss. However, we program this with specific settings for the Crysalli chiller systems. It also comes with the bracket and an electronic sensing bulb, a couple zip ties, and some hardware to secure this to the existing bracket. It's backwards compatible, fits into the same mounting bracket, same mounting holes as the old one. And then most importantly, it comes with this Crysalli installation procedures. It's all in color. and we give all the step-by-step instructions on how to remove the old one and how to wire in the new one. And then on the back, you'll see there's some pictures. So positioning of the new sensor is going to be unique to depending on what chiller system you're working on. So make sure you reference this when you're installing the electronic sensor on the evaporator coil. This is also available in a digital format online. Now we're going to install the electronic ice bank controller. We're going to install this control box to the bracket that we removed the old one from. As you can see, this little terminal plug here is connected to the sensor. It's important that that's engaged and on before you attach the bracket, because once you mount it up there, it's going to be nearly impossible to install it. Should come already engaged, but if for some reason you've removed it or it's not, make sure you connect it before securing this to the bracket. So I'm going to go ahead and install that. I've pulled the 3 wires coming from the electronic controller into the electronic box, and now I'm going to connect. The black is going to go to IBC1 terminal, which is the top one, and then the brown is going to go to IBC2, and then the white is going to go to W4, W3, or W2 terminal. Any of those are fine because they're all connected. Connections to the board, we'll go ahead and secure the cover plate to the electronic enclosure. So now we're going to route the sensor up to the evaporator, and for simplicity what I usually do is I just pull the sensor out from the bracket, and then I'm going to route it around the chassis. And once I get it through the chassis, I will go back and install it back into the bracket. Next, we're going to install the sensor and the bracket onto the evaporator. So it just slides right over the top of the evaporator, and then we're going to use the zip ties provided to secure this bracket to the evaporator. Very important. I've seen this happen where somebody's actually installed it onto the water coil. If you do that, then the ice bank will build up and then end up freezing the water coil. So must be installed on the evaporator. And this happens to be a Crysalli unit, and the location of this, as I mentioned earlier in the video, is critical for depending on what model. So reference the pictures and the detailed dimensions on location that's in the install guide. This particular one is going to be 7 3/4 inches from this back wall to the location of where we're mounting the bracket. So I've taken some of the supplied tie wraps, one of them, and I've secured this bracket to the evaporator. And now what we're going to do is this, the line that's feeding back to the controller, we want to make sure that it's pulled away from where the ice is going to build up. You don't want it overlapping, because if it overlaps and ice builds up around it, then it'll send a false reading back to the controller and shut the compressor off prematurely. So we want to pull this away from the sensor, and then I usually just tie wrap it to the water coil. Now that the sensor's in place, we've secured the line to the water coil. Next step is filling the water bath, putting the panels on, and getting this back underneath the cabinet. For details on how to fill the water bath and start the system up from here, you can refer to some of our videos on filling the water bath.